Hi. So today we're looking at electrical power and potential difference. Again, we're focusing on what happens inside your home, but we're kind of back to the kind of classic working things out with a simple equation. And I know you love an equation. So we're going to be able to calculate the power of different electronic devices, but we'll start with a little bit of review of the previous lesson. Can you name the three cables inside a plug? What are the job? Oh, sorry, what are the values for a fuse? And then what is the job for a fuse? And why don't all devices have three wires? Pause and answer the question. Once you've answered the question, unpause and we'll go through the answers. Okay. Pen. Getting ready. Pen's not working a lot very well today, so we'll see if it works. What are the three cables inside a plug? We have the live. Yeah, oh, it's in black. Live, neutral, and earth. Excellent. What are the values for fuses? I spoke. There are other values, but the most common are 3, 5, and 13 amperes. What is a job as a fuse? It's a kind of safety device that breaks when there's too much current. And why don't all devices have the three wires? The earth wire is only for devices that have metal casings and metal outsides. So if your device doesn't have a metal outside, it won't need a third wire. So like maybe a games console or a DVD or Blu-ray player, maybe I don't know, a kettle, plastic outside, don't need that third wire. New equation. Here we go. Power is current time voltage. Power is P. Current is I and voltage is V. Write that one down. It's really important. Do it. Well, what do we measure them in? What's power measured in? What? Indeed. Yes. Power is measured in watts. Current is measured in amps, and voltage is measured in volts. It's really disappointing doing this. You can keep this power is measured in watt going for days if you're in a real classroom, but here I just seem a bit strange shouting at the computer. Power is measured in watts, current is measured in amp, and voltage is measured in time. But that's not the only method to work out power. There are multiple ways to work out power. And let's look at what power actually is. Power, we're missing a line. Hang on, see if I can draw it in. There we go. Power is actually, like if we put it down to like base units, the most fundamental power is energy divided by time, joules per second. So when we're looking at power, when we're talking about power, it's really handy to think about it in terms of how much energy it delivers in a particular time. So the example I've given here is 1 watt is the same as 1 joule per second. If you have something has a power rating of 1 watt, it delivers 1 joule in 1 second. In 2 seconds, it will deliver 2 joules. And in 5 seconds, it will deliver 5 joules. So 1 watt is 1 joule a second. If a device has a power of 500 watts, it delivers 500 joules a second. 500 joules in a second. And if it has a power of 234 watts, it delivers 234 joules a second. Power in wattage is another way of saying how many joules per second. How many joules per second. So a higher power gives more joules every second. 20,000 watts will give you 20,000 joules in a second. That's a lot of energy in a second. Okay? So let's have an example of energy transfer. So let's do this. P is E over T, which is almost as the triangle. So power is 40. P is 40. That's not idea 40. 40 watts. And T is 30 minutes, which is 30 times 60. So 30 times 60 is, oh, wow, this pen is going crazy. So we need to do power times time equals 40 times 30 times 60 equals, it's a calculator, probably should be able to do this in my head, but I can't. 40 times 30 times 60 is a power. Energy transferred is 72,000 joules. 72,000 joules. Simple. Here we go. Now, chance for you to use the equation. Rearranging, remember, P, E, T. So that's it as a kind of triangle. So question number 1 is, a hairdryer converts 40,000 joules of electrical energy to heat energy every minute. So what's the power? You've got a joules, you've got a time. An electric iron which converts 720,000 joules of electrical energy in 10 minutes. Also time. And a microwave that uses 1.5 times 10 to the 6 joules in half an hour. Really important to convert the time into seconds. So don't forget that before you do any of this. So do those, pause, do the questions, unpause. I'm not going to go through the answers now. I'll give the answers at a later date. You done? Splendid. So there's a bit more with this power. So do you remember what happens when current flows through something? It gets hot. Excellent. So when current flows through something, it gets hot generally. If current flows through something with a higher resistor, what happens? Higher resistance? Yeah, it generally gets a bit hotter still. Higher resistance means it's harder, so those wires heat up. So if we want to work out the power that is lost, so for example, if you plug something in, it might draw lots of volts out of the mains, but it might not use it. Some of it's going to get wasted. The power that's wasted is heat. Is given by this equation. Power is equal to current times resistance. Current squared times resistance. It's actually the same as the other equation. So P is I squared R. If you remember, before we had P equals I V, and we also know that V is equal to I R. So if we combine them, P is equal to I, and instead of writing V, we write this, I R, or P is equal to I squared R. Maths. That's, if you want to know what power is lost due to heat or due to current, that's your equation. So here we go. Another set of questions. What I need you to do is just copy down the words that are missing in the correct order. I don't need you to write all of that out. If you'd like to write all of that out and use it as notes, that's fine. But you've got 1, 2, 3, 4, 5, and then a equation at the bottom. So power is the energy transferred in device in each. Number 1, number 2, number 3, 4, and this is number 5. So pause, answer the questions, write down the answers, then we're time to move on. Here we have more examples of questions. This one I do want you to copy it down. So here we have the table. Surely you've drawn the table lines in. Power, current, potential difference. Copy and complete the table. What are the missing values? It's asking you to work out potential difference for the numbers 2 and 3 and the power for the first one. And then we have another question. A television has a power rating of 150 watts. A light bulb, a power rating of 40 watts. A dishwasher of 1,500 watts. Calculate the total energy transferred by these appliances if they were used for 4 hours over the course of the day. How much energy do you use if you're watching TV for 4 hours? How much energy do you use if you leave a light bulb on for 4 hours? And how much energy would you use if you use a dishwasher for 4 hours? Which was that? A, B, C. TV, bulb, and dishwasher. Sorry, the pen is properly crazy. And then some smaller, simpler questions. In fact, there's 2 rows of them. I'll read them for you because I'm kind, but you have to answer them yourself. What is the power of a 12-volt, 50-amp light? What is the power of a bulb rated at 5 amps, 6 volts? A 600-watt electric heater is connected to a 120-volt source. Calculate its current. What is the power of an unknown device if a current of 35 milliamps passes through when connected to a 3-volt supply. A portable hairdryer plugged into a 110 amp volt outlet has a current of 10 amps flowing through it. What is its power rating? And on the last slide, a microwave oven has a power of 1,800 watts. The potential difference from the mains is 230. What's the current and what is its resistance? A computer uses the 3.5 amps at 110 volts. What's its resistance in ohms? And a device has a resistance of 11 ohms and a current of 12 amps. What is its power and potential difference? So there's not too much, and the equations are quite simple, and you're just using them again and again. Remember, write all your answers down and practice. You can do this. I believe in you. Love you. Bye.